There we go. Let's hope that I have some sound today. I've prepared a big show for you guys. So I will show some of the projects I've been working with. Couple of small announcements. First, would be great if you guys could stay here later and that we start finding the teams to, then it's okay, you can come in the afternoon to actually work on it, but I want kind of have everybody here to form teams. And so today I'm starting with a little tiny bit which we have mentioned already in the last lecture, the power management on the ESP. So I will show you a little demo how to use that with ulno.IoT. And then I present you various IoT projects with a focus on the work in arts I have done. So the idea is that you can put this ESP into a deep sleep mode. And then it consumes very, very little power. So you might actually want to, for checking, but we don't have these devices, but there are these little nice USB toys. So they're these kind of USB sticks which actually show you how much power is used. So they have a little display and you can put them between a USB connection and the power outlet, and then you can see actually how much these devices use. So if you later in the lab, we will actually have a couple of minutes to actually replay this. If you want to have one of these devices, let me know, then you can actually see this in effect. So what you also need to do is, if you wanted to wake up automatically, you have to wire D0 to RST. And then you can, in the code, say, okay, in 20 seconds, go to sleep for 30 seconds, or probably usually longer. So you would kind of say, in 15 seconds, go to sleep for 5 minutes, and then wake up. If you, for example, have something like temperature, yeah.
Why do you have to wire it? It's like
because the real-time clock stays awake, and that sends an interrupt to the RST port, which is the reset port. You don't have to wire it if it's just a button. So you can also build something where you have to press a button to wake the system up, or where the button press triggers directly sending something. So if you basically wire to the reset button, to the reset port a button, then you can use the button to wake it up. So you basically have to put 3 volts, a small 3 volt spike on RST, which basically is the same like pressing the button, the reset button, and then it actually sends something out. I think some of you in the lab actually built some kind of button mechanism like that, which just right after it was started sent out something. So this is the same idea here if you want to use the deep sleep. But you have something like, in my example, you have a temperature sensor. You all know the Dallas sensor here connected to it. Then it needs to have the D0 pin wired to the RST pin. So how does that look in ulno.IoT? Let's open that up. And this is under sleep test. And let's make this a little bigger. So if you want to use that in ulno.IoT, you have to define your devices. Remember, for the Dallas, you can also do DS18V20. It's the same command. And this thing, you can use a start function in ulno.IoT, and there you have to give 2 parameters, so you can actually put in uhelp deep sleep. And there you see it has time from now in milliseconds, and it has the duration in milliseconds. So basically means how long shall it be awake. So you need to give it a little bit time to send its initial updates to the network. And then it says, okay, then you go to sleep, and it falls asleep. So let's connect this guy to it and see what is actually happening. Should show you my Node-RED flow for that too. Maybe make that a little bigger too. So there's no sleep test temperature at the moment. Let's open Node-RED here. And let's see what I've done here in sleep test. Yeah, see, there's actually temperature reporter which sends this to a graph. So at the moment it's not plugged in, so we don't have any temperature data. So let's plug this in and maybe at the same time also put a debug node here so you can see what is going on. And we can switch between the two views. Deploying that, still don't see anything here. And let's plug this guy in. So it has its normal blinking for starting up. And then it should soon come and send us the first temperature values, yeah? So you see now every 5 seconds it sends the temperature values. And soon it will stop because it goes to sleep. See, now it stops actually sending the temperature values. And if we would measure now, we would just measure this stupid LED which is on here, which is probably more than the this guy is actually consuming now, and then it should wake up in 30 seconds again. Should make that. Come on. Yeah, see, now it's booting up again, and soon we should get more temperature values. And there we are. So we can also look at the console, what it shows there. So if something goes wrong, you can now see we just got the message that it falls back into deep sleep, and you will see in 30 seconds again that it boots up. See, there it comes to the reset message, it subscribes again and goes there. So important to remember is it will forget everything. So if you have kind of an actor connected to it, it will forget its state. So you might have to resend it, or you have to kind of build this in that there is an undefined state. It's just like rebooting the device when it comes back from the deep sleep mode. Now there you see it's a couple of temperature sensors, and then it goes back into deep sleep. So that is relatively easy. And I want you to experience that yourself. What else problems do we have if we use deep sleep mode? Do you think that something in ulno IoT could be affected? Think about over-the-air updates. That's pretty hard when the device sleeps. So it's a cool thing for managing power, but actually managing updates, you have to find the right time interval, or you have to basically rewrite the over-the-air mechanism in ulno IoT that it's basically taking a look if there's a new update and then pulling it. So at the moment, over-the-air updates in ulno IoT are pushed, but basically smarter is it to have a pull mechanism when you want to do over-the-air updates. Good, so that was our little introduction before the real show starts. There's actually something. So think for 2 minutes if there's a project you have already done, and write down one line in the lecture note, lecture record, where this power saving could have made a lot of sense in what you have done so far. Think a minute, just pick one example.
But I can't awake it from pressing a button.
Oh, yes, I think we can actually see that. If I press the reset button on it, it should actually wake up. Let's try it. This is basically if you use 0 here for the second time, the duration, so if you skip this parameter, then you can only awake it with sending a signal on that port. But it doesn't send it automatically. So basically, instead of wiring RST to D0, you have to wire it to a button. So often you have some kind of game controller or something like that, and then each time you actually start using it, it also pulls this one line up here. And this way, so if you basically wire it to the actual GPIO port you want to measure, and another port, and this RST port, you can use that to trigger that your system fires up. Of course, it needs kind of 10 seconds to be in the Wi-Fi, so you have to kind of factor that in. It's not instantaneous. Especially with the 5 seconds of ulno IoT, having this initial phase, so that something there could be optimized too. But for that, I have to remember the reset state and see how the system was actually reset. So if we do console serial here, so is it sleeping now? Yes. See, it's now actually asleep. And I just press the reset button and the game starts from the beginning, which is basically the RST port on here. So I can also just wire 3 volt to it and then have the same effect. Okay, have some ideas where in your projects you could use it? 2 volunteers?
We had a servo motor in our project,
Uh-huh.
and we couldn't stop it ultimately. It was always turning a little bit, and I think with mode we could turn off the
But it could eventually work. I don't know. So I think also if you would have switched and really put all the ports to 0, it might have stopped too. So instead of actually using the ports as a PWM port, but as a normal GPIO, I think if you could have just and another option is no, that wouldn't be. So you could have actually used the relay in addition to give it 5 volts or not 5 volts. So basically, if you have these cases, you might want to use a second GPIO port to switch on the power or not. But don't use the GPIO port for driving the motor because the motor draws too much current to actually do this. You would actually need 5 volts, then a relay, and then wire a level shifter or whatever, and wire it there. But would be worth a try if it sets these ports to 0 anyway when it sleeps. Other ideas?
We made the rollator emergency system.
Yeah.
And for the rollator, it would be very nice.
If the system would usually be in standby. Yeah, of course. That would be probably easier and could also work not with the auto wake up, but basically with the just triggering when the thing actually falls down. That's a nice example, yeah? One more? No? Okay. Let's continue and see what we have there. So everything you're excited about, we're kind of more and more going into project mode. So in the last lectures, I'm trying to line up some external speakers. So we will have actually a person from a business accelerator who works in Brazil and in Chicago. And she takes one big entrepreneur. So she promised to bring even another entrepreneur in. So on Monday, we will have some preparation about how to do a startup in Internet of Things. And then hopefully you have lots of questions for these 2 persons, which will then sacrifice their morning for us because they're 3 hours back to talk with us. And I hope even to get another entrepreneur on the next day who works here in Munich, but don't know yet. So that's kind of what's coming in the end. And you should switch to project mode. So this is a big project. I intend to have 4 to 6 persons in there. And yeah, as you see, the most important thing for me is, again, the scenario. And so I want an IoT scenario covering at least 4 different domains. What are domains? Yeah, comfort, entertainment, wearable computing, health, art, security, privacy. Yeah, so I want you to have something which covers at least 4 of these domains. It can be a long scenario, yeah? So it can be a long playthrough and actually seeing these different domains. It would be nice if, so you don't have to implement everything in hardware, but it would be nice if most of it is implemented in hardware. You haven't seen all the sensors. What students like before, there's an alcohol sensor in there you could use. I think we have a heart rate sensor you could use. And there might be some small other sensors, the barometer stuff, and so we haven't done yet, which might come in handy. Or maybe you have an idea of something we haven't done at all. Talk to me, maybe we can implement it or at least approximate this, yeah? But don't limit yourself in your creativity with the hardware available, but let's then reverse look what can we actually implement with the systems we have here. Yeah, then I want you that you fully specify the scenario into a playable pitch. And it needs to be enacted by all team participants. Yeah, so everybody needs a role in playing through this scenario. I want to see that everybody is active. It can be just a minor role, can be just a presenter, can be just a narrator or so, but this needs to be in the project for the final presentation. So again, realize the scenario in soft and hardware, document all the development, including the problems like we have done in any lab work here so far. I want to see in the project report who has done how much, or in the respective portfolios mentioning the project report. So this whole thing should be wrapped up into a sales pitch and presentation, including the whole playthrough with the real hardware of the scenario. And this whole thing needs to be put into a video. So I want you to record this and do a little bit of editing to have a 15 to 20 minute video. Because if you want to do it live, it will go wrong. So rather have it all in video, and even if you cut things so together that this is not a real live presentation, I prefer that than a playthrough where lots of things go wrong. Practice and record scenario playthrough as a video and link it in the portfolio. So you can have it private or public. Some people last year made it actually public, but if you make it public, I might actually show that to other students at one point, which is, some people might like, some people might not. So I would appreciate if you allow me to reuse some of these videos later, but if you don't want to, it's fine too. So the idea is a little bit like that we have a round of investors sitting here who give you further funding for the project. So you want to present it in a way that you ask basically for money for continued funding and making it bigger what you have started here. So you use your prototypes and you want to convince basically a panel of judges to do that. A little bit, I don't know if you guys have done a hackathon, so a little bit like what you do in the end of a hackathon. This doesn't need to be a project which really turns into a product. So also kind of a non-profit idea is a valid idea. Yeah, so if it's just good for the community, so if this is good for awareness, even if it has a pedagogical effect, this is also a valid goal from you. You just want more funding for continuing doing it, yeah? And it doesn't necessarily mean you want funding to do your first product run with it, it's just for continuing the words. Let's think about seed funding for first angel investment into what you want to do. I have to approve what you guys are doing. So on next Monday, we have to come to the point that your scenario is done and that you can basically start implementing it. But I want you to take time over this weekend and until the end of the first lab next week that you actually make a really nice scenario. And then you take the scenario, kind of cut it down in tasks and give the tasks to the respective team members and start implementing it. Okay, yeah, and on not next week, but the week after, we have our final presentation day. We will show the videos and give some room for explanation and turn everybody else who is listening basically into the judging panel, and we will see what the coolest project was. You get an idea? Yeah, so the most difficult task is finding the right team members and finding all the domains you want to cover. Yeah, so if you kind of compare your ideas, you want to make sure that it covers a lot of domains from this area. And if you don't think you cover enough, just talk to me and I might say, it's fine, you have everything. So it should be a little bit interactive with me so that I kind of sign off your project. So, and now we will start the big show. I will show you some of the IoT projects I have been involved in and give you of some other projects where I might be involved in into the future some ideas. So I want to stifle your creativity at this point. Of course, I don't want you to just watch and enjoy. Again, some stuff needs to end up in the lecture record. So for each project I show you now, I want you to say, is this really Internet of Things, or are there some things where you think it's not completely Internet of Things? Yeah. So you have all now an idea, personal idea of what is Internet of Things and what is an Internet of Things systems. So judge it by these standards you have. And if it is, why is it? If it's not, why is it not? Second, highlight two of the projects which you really, which kind of were inspiring for you, and just give it a grade and say, okay, this is probably relevant for my potential project. Yeah, so here I have to follow up. While you're doing that, also make a little sketch of your scenario idea. Yeah, so that can be just the general description. Doesn't need to be a fully spec'd out scenario, but just some of the domains and the areas which come into your mind when you see my project presentations. And anytime you think, okay, now I have an idea for my project when I see this, but how can I do that? That's an important question I want you to write down and use these questions in between or after the presentation and ask me, okay, I had this idea I could realize something with lots of LEDs, but I have seen we don't have LEDs, so where can I get these? Or I have the idea to use a powerful motor to do something, how can we do that? Yeah, so kind of this idea, so I had how can I realize that? Because you showed me this, I want to do something similar, how can we realize this here in class? Okay, so I don't have the first point on the slides I uploaded yesterday. So in addition to the points which are in there, also judge each project in how far it is Internet of Things or not. Because now I have to start here. I will show you now my original entrance into Internet of Things, starting from my PhD, the eHome demonstrator. You will soon know what the eHome demonstrator is. This is what I used in my PhD. Then I will show you some do-it-yourself remotes. I will show you a project which we developed for rainwater management by smart communities. We will talk a little bit about virtual libraries, or libraries in your pocket. And then I show you lots of projects in the arts. And the first one will be the Magic Owl. Then I will talk a little bit about performance support, where you can use Internet of Things in the theater. Nino is also kind of a smart home arts project. We will talk about two pieces I have in the Museu Nacional in Brazil, which is with artists I met at Nino. Then I will show you a couple of projects where LEDs are involved, and kind of encourage you in the end to visit the Ars Electronica Center once again, because there are a couple of cool arts projects which clearly are in the Internet of Things domain. So apart from the last two projects, actually show you only a picture of one of these. All the other projects I have been involved in. So that's a young version of myself, and I still like Legos. And you see that's kind of a little bit of an model home, and we didn't know that they will be called smart homes, so we called them e-homes 10 years ago. So this is the first e-home. It's actually the second e-home demonstrator. The first e-home demonstrator is much, much bigger, was a huge thing out of wood with real components, but it turned out that nobody wanted to send me to conferences with this, so this is why I built something from Lego to actually do that. But last time we actually did have some students who realized some of their projects or scenarios and played them instead of themselves with little Lego puppets. You just have to, because I said everybody has to be in the playthrough, you have to say who played whom. So I just need the role. So I encourage you, you can use Legos in your final project. That's good. Lego is always good for prototyping. Everybody loves Legos, also investors, so it's not a bad thing to have Legos somewhere in your prototyping. Not everything needs to be 3D printed. I've asked if you need something 3D printed, we have in principle access to the Maker Lab, but Jens Kröscher asked me that we send him the STL files and he would actually print it for us. He doesn't want the student actually in there. So if you need something 3D printed for this, talk with me or talk to Jens Kröscher directly. Yeah, we called that at the time ubiquitous computing or actor sensor network, but now it's Internet of Things. There is a video of this in the net if you want, out of nostalgic reasons, want to see me 12 years ago showing this off. Feel free to watch that video, but you don't need to. So a little later, I built version number 3, which is kind of this little wooden box over there, which sits now in Brazil. So it's a bit more real because it uses real components. And yeah, I will show you this in action. So Encourage I was building this for a makerspace, and the idea was to make an easy way of doing home automation at home in existing system without damaging and remodeling too much in the house. So let's find this, and as first a smart switch, and so we came up with this nifty device here. So these are the typical light switches in the US.
The nice thing is you can actually even still switch it yourself if you want.
And you see that's basically just the little servo motor which you also have. And you can basically just screw this whole thing on top of an existing light switch and still use the light switch. So not everybody might really enjoy doing that, but it's kind of for a maker approach, you can actually use that. And these light switches are also put into the eHome Demonstrator 3, which I will show you now. And I don't show you the original, but kind of the second movie I made with it, which shows some advanced features of it.
Okay, as promised here, a little quick teaser for some new features of the eHome Demonstrator version 3. So I will just start as I usually start. So we enter the house. So I take the phone and open it there. Then it starts the unlock function. Switches on directly the light.
Welcome back home in the eHome Demonstrator version 3. The current time is 23:10. I measure 82 degrees Fahrenheit in the living room.
So
Have a wonderful time and enjoy yourself.
So it now actually welcomes you when you come.
It's a new feature I'm presenting.
Let's exit this, switch this off, and let's assume you want to switch this one on.
You see there are lots of BEMOSes
And
in every
now
room.
let's assume you want to go to the living room and enjoy some music. And you say, turn music mode on.
Okay, get comfortable and relax while listening to the music.
It switches off the lights and starts music to listen to. So we just stop it again and tell us the time.
The current time is 23:11.
Can say us the temperature.
It is currently 62 degrees Fahrenheit outside. Expected precipitation is 1 millimeter.
And we can end this.
Goodbye. Have a great day. I hope you enjoyed the tour.
Okay, I hope you did. So you basically see I have several rooms. Each room has some switches. Each room has RGB light. One room has a media center in there, and the media center is also used to give the talking and the feedback. So you can actually turn one of the little Raspberry Pis you have there into install LibreElec, which is basically Kodi running in it, and Kodi has a nice API, and you can do lots of things in playing a video, playing sound, and using it for speech output. But you have also seen that you can use this directly in Node-RED. We will actually have a little bit of an example here where I use Node-RED to do the speech output. So there are various options to actually do that. Let's see what's next. Before we go there, all the code for the eHome demonstrator version 3, in terms of how all the devices which are in there are programmed, is here in my examples. So you can see I have the bathroom, and there's a light and a remote, and then basically the same everywhere. Yeah, so all this kind of Vemoses I have in there, the code you find in there. It's nothing complicated. So most of the things I show you now, you find in the examples on the ulno IoT project. Okay. Yes. So I had one project where I wanted to do something for kids and kind of encourage them to work with electronics. And so we built actually joysticks. And so you see the old nostalgic joystick, which basically, use a battery and this is an old version of an ESP development board. And so we use that to control a game I programmed, which is a Pac-Man style game. And so I have a nice nostalgic effect, and nice to have these external controllers. And I show you something else, which uses the same thing. So I have here this battery and just a couple of buttons. So I let this boot up. And if things work, I should now be able to control my presentation. See, so I go forward, I go backward, and I go forward. And so I can now use these buttons to have my own PowerPoint remote. So you can build something that easy. But so how does that work? Let's look into the Node-RED, which is here. So this is what is happening here, and this, in the end, so you see I have all these different buttons on the remote, and then just turn them into commands. You know that already, how that works. And there's this magic inject key here, and inject key uses just a program for the respective platform. So in Linux, it's xdo tool, but you find on Mac and Windows different programs how you can actually inject a key into the running system. So, but I just show you here what inject key does. And need to do this a little bigger. So you see, basically it sends the key I give as the parameter to it with xdo tool to the system. Xdo tool is the key inject program on Linux. There are respective programs for Mac and Windows if you want to do that. Cool thing here is you can use that, also to interact with the game, or you can do any type of interaction with a real PC where you don't have another way to do the interaction. So if you anyway have Node-RED on the PC, also remember you can use that to start a video, to start any program which is on there. And then afterwards you can use this key inject mechanisms to interface with the program. So you can just install Node-RED and then hook it up to another Node-RED installation. In this way you can integrate something weird on a PC into your project. So I hope that sparks a couple of ideas. Let's go back. Then we had this project where we wanted to do something good for the community. We still wanted to get some money, which we didn't end up getting, but we were pretty close. So the town Baltimore has a huge problem with their rainwater. So rainfall is pretty hard, and with all the recent weather change pattern, it gets even more extreme. And the town has to pay a lot of fees and punishment fees when the rainwater drains somewhere where it shouldn't drain. When it basically comes out of the channels and then some dirt comes in this and kind of flows out, then the city has to pay punishment fees because they don't know where the biggest problem is and there's no warning mechanisms for this in place. And there's a lot of poverty and unemployment in Baltimore. And maker spaces and kind of spaces where people kind of learn new things and new crafts are flourishing. So the idea was, how can we connect that together and make this, make something out of this. So teach people at the same time and do something good for the city. So basically local empowering to make the city or the community smarter. So for this we needed something really cheap to build. So the idea was to build a water sensor. And so all these components are less than $10 together. And we needed something which was water resistant or waterproof and could kind of sit somewhere in the canalization or somewhere where all this water is. And you know this spiel now. So we get actually a message when this is happening. And now see, now it's wet, and now it will continue sending this all the time. So let's dry this off. See, now it's dry again. And as soon as we put water again on it, we get the message again. How does this work? I guess you have this already in mind. It's a little bit more complicated than you think because I use all this audio stuff here. Again, it only continuously leave wet out, and I don't want it to ring all the time, so I limit the messages. And the cool thing is you can actually read a file and send it to audio out, and this is the map you can actually hear here. And at the same time, it shows a notification on the screen. So basically, let's do it once more. Then you can see that there is a message coming up in the right corner. See, there was something. And if you do that on your phone, you see also then the notification on the phone. It also rings there. So the demo we had was actually, yeah.
So, and how could the city of Baltimore use this system?
So you would actually have now thousands of these sensors and a couple of Raspberry Pis where that's connected, and then it collects this data, and then you get a big map where is the water at that time. So basically you would cover the whole canalization system with it, have the points where they collect the data, and then another central point where then all the data is coming together. And then you can fine-tune the notifications which are run where the critical areas are, and then open some floodgates earlier. The idea was, okay, we can really cheaply build all these infrastructure and sensors, and maybe even could employ local people to replace the batteries when things kind of break, and this way, yeah, do a lot of community engagement, get people to this point. They want to probably learn more about that, and maybe then empower the local communities to become entrepreneurial, to start learning again, but basically getting people off the road. So that was this guy.
And why didn't they pick it?
Because we had too much competition. And because we were kind of in a university context, and it was, I think, not academic enough. So, yeah, we'll try one day again. So we still think it's a cool idea. But
How do they do it now? When they...
they pay the fees. Every 3 months, they pay a couple of $1 million in tax money to pay for the sins. We wanted 50,000. Yeah. Don't ask. Well, at least I can use it for teaching now, this project, you know. So it's not so wasted. If you do something in that direction, I think I will be more generous in terms of accepting this, and I like this idea. So there's another project which is called the Virtual Library, and there are a lot of countries, a lot of cities, a lot of locations in this world where there's still no real internet, where people are poor, people don't have access to knowledge, where libraries still have a lot of meaning, people like to read and have books. And in this realm, one of the colleagues of my wife has actually started building or shipping Raspberry Pis with a Raspberry Pi image which is called Pirate Box. And this is basically just turning the Raspberry Pi into an independent Wi-Fi router, and if you log into this Wi-Fi, you can share the content on it. Yeah, so you could connect it to the internet and then actually really share internet, but it's more interesting in having something, you go to these locations and you want to give content out, you want to give books out, teaching material out in a quick way without giving out a USB stick to everybody, because most people don't actually have computers. So what everybody nowadays has is a phone, is a smartphone. So most people can connect to Wi-Fi, even in poorer regions, and then download the content on their phones and access then the content on the phones. Or you could give this to a librarian there, and then anytime you are near that building, you can access this content. Often these regions also don't have power, but a Raspberry Pi doesn't need much power, so you can actually use a small solar panel and a backup battery and basically provide this infrastructure for free. It also allows people to create their own content, upload their content, and then share the content on it. And if we would switch the whole thing based on ulno IoT, you can now argue which sounds worse, Pirate Box or ulno IoT. Actually, we have a little bit problem with the name Pirate Box in there because we don't want to encourage pirating things. But it allows chatting on there. So my vision is a little bit now to use something more Node-Reddish to kind of customize this for the current environment. We could add some temperature sensors. We could also give something for the local community connected to a weather station, and then have this different current content there available for the respective community where these devices are deployed. So that's the virtual library. And let's go to the arts project. Oh, I forgot actually to plug some of these things in. We have used that one. So I wanted to have this plugged in before because it will blink a little bit. It would have maybe caught your attention. And so when I was working at the Makerspace in Washington, D.C., basically as my entrance exam, I had to learn to sew, and to learn a sewing machine. And then I met the lady, so the lady you see in the back there is the manager of the Makerspace, and the lady in blonde was a customs designer. And so I was working with her to actually say, hey, we should do something with Internet of Things and clothes. And she was doing these super cute owls, and she already had blinky eyes in there, but you had to basically switch them on manually. So I said, we can make that remote. And then we were thinking, we need something which we can have, because the Makerspace had big windows, but it wasn't opened all the time. But we wanted to still attract people also when they weren't there, or when the Makerspace wasn't open. So we thought, maybe we can let them interact with the things we do in here without actually entering the space. So I had to come up with an idea, how can we do something where they can just use their phone and then interact with the pieces which are behind the window. And so we did the following. The owl.
I'm showing the owl project which we have finished here now. And so we actually scan the QR code, and then, oh, it's really hard to see. So then actually the LEDs light up and show different colors, and then they switch off. Where I go, can you scan again? I should rather focus on the owl.
You hear 3D printers in the
Oh
background.
yeah, there you see the lights turn blue and red, and massive, and then green and yellow, and then it turns off. That's it. And that works wirelessly, even if we at the moment kind of feed power to the owl. But yeah, I think it's a success. Thanks for helping, Amanda.
Okay. And I didn't take the owl, but basically this is the owl. Yeah. I don't know if you have seen it blink. So it actually has an attention capturing mode in here. So maybe also for our international viewer, I should show the fake owl here. So the fake owl. So if things are working better than with the other one, yeah, let's now try this. Does anybody of you have a barcode scanner on their phone? QR code. Please, one person scans this, yeah?
Ah, doch, ich hab schon, wir können das.
See? And the eyes blink.
Oh my god.
And you end up on which great page in the internet?
I think ulno.net.
So, I hope you, at least not many students, appreciate the feat we have actually done here. Yeah, so you are just random people who access this through the internet and make my little thing interact here and blink. And so how is this done? We first tried to use if this then that, but that was kind of not really instantaneous. So we needed something else. And let's look at the code. Okay, so actually this is the first time you will see some more advanced IoT code. So I think this is still easy. So usually your programs are like this. But there's a class in IoT which is called animator, which can do anything which is frame-based. Yeah? And so the animator can have some commands. And so here this command is basically colors. And this command is actually just setting some initial parameter for an animation. And then it has a frame builder. So this will actually be called in a specific frame rate. So we have here 30 frames per second. So every 30 times per second, this thing here is called, and which you see here basically is moving through colors. Yeah? So it computes new colors, and depending if the animation is active, it does this. And so it has two animations. One is this cycle through the colors, and the other thing is this winking. So there's another function in ulno.IoT. So you have seen the start function, so this is actually to execute things at start. But there is also a do later command, which is a scheduler. With do later, you can basically push a function on a stack, and this is basically calling itself here. And see, so randomly between 60 seconds and plus a random number out of 30 seconds, it actually restarts the winking. So I don't know if you have seen it, but so sometimes just one eye of the two eyes here blinks up and goes down. So every approximately 75 seconds, you should see this little animation here. This is done with this do later. So if you want to do some blinking, then you can do this with the do later. We also had the same thing in the water sensor Where's the water sensor? Right, water sensor. The same thing we had also in the water sensor. No, this is here set up. See, also the water sensor has this do later function here, which it calls, and then this is this blink, and that uses do later again. So basically to switch on and off the lamp. So with this you can do some blinking in kind of pushing functions on the stack. Or if you want to do something more, you need the animator object to realize that. So, but how do I do the connection with the owl? It's not that hard. So you see, I get something from something CGI-like and send it to the actual local animation. So you will see it just uses a different port. So, but what is on this port? So what I basically do is I tunnel from my server, the MQTT server in the network running on ulno.net, I tunnel back the MQTT port. So how do I do that? So the big magic of port forwarding. If you anytime want to connect things across different networks, is a very helpful, quick way to make that work. But I would like to see the whole thing. Here it's kind of going in the next slide. So the big command is here, this SSH command, which uses this port forwarding here. So you see actually the local host 1883, which is the MQTT port on my server, comes out to 1884. I used before to have an open MQTT server on my server in the internet, and then use certificates to connect the two MQTT things. It's relatively easy in Node-RED to connect to a secured MQTT server. But sometimes it's easier to just use an SSH connection than kind of generating all the certificates and doing that. So the quick hack usually is using SSH and port forwarding. The clean solution is to use certificates and SSL. Yeah, but both for prototyping, doing something with SSH might bring you quicker to your goal, and you can show the same thing. So then I see I can also trigger the animation of the owl manually. So I can do it here for testing. And yeah, again, so that the international viewers believe the animation is running. So that's the stuff I can actually show today. Now we come to the bigger projects. So I've worked in theater. IoT was installed in the theater. And so there's a festival in Washington, D.C. It's called the Fringe Festival, where basically small theater productions get a chance to show off what they do. There's kind of very alternative, very artsy plays which are there. And basically the same guy I was developing the water sensor with, he's an innovation lawyer, was giving his own dance-related documentary in this on that stage. And so you see him dancing there. So with this guy, I was building the water sensor for Baltimore. And this was our videographer. And so the whole performance was basically dancing through life. And he wanted people to decide during the performance if he is a geek or a dancer. And because he had all this technology, he wanted to be branded as a geek, but because he was dancing so much, everybody said he was a dancer. We would have liked to actually put stuff into the clothes and would have seen the election results directly, but he kind of put me into the mix very, very late. So the problem was he came to me and said, hey, Uli, we use Windows 10 and PowerPoint to have the backdrop here, and it updated during the performance. So you know that you cannot control the updating mechanisms anymore in Windows 10, so nothing professional, in no professional setting ever you can use Windows 10 nowadays, because it might actually cheat on you. Even if Windows or Microsoft says you can control the updates, you don't really know if you have managed to control them. So they might still, if you haven't done the updates long enough, they might just branch it. So I highly advise against using on a professional setting where you use something to display something, a Windows 10 computer, to show that. So we said, okay, maybe we can just use a Raspberry Pi instead to run the, I think it was a 15 gigabyte PowerPoint. And so there's actually a function in PowerPoint where you can pre-render the whole thing as a video, and then you can timestamp it. And so what we did was we used the video playing functionality of the Raspberry Pi and jumped between the different points in there. And the cool thing was they just had, now for the next shows, they just had to plug in the Raspberry Pi, connect it to the projector. It had its own Wi-Fi networks, and they could use then both such a remote here and a cell phone to control jumping between the different points. And from that point on, the performance was pretty smooth. And the cool thing is, before we had kind of a guy sitting up there and watching and praying over the Windows 10 computer. Wasn't necessary anymore. So you could actually bring this person down and help actually guaranteeing that the show was running smoothly. So if you now take this a step further, you could of course also control the DMX lights thing up in the box. So this is all electronics up there, which can be already remote controlled. So the idea or extending this is you can very easily control with a Raspberry Pi most of the things which need to be controlled in the light box from remote. So we actually thought of opening a company where you could send your PowerPoint and you get a Raspberry Pi back. And then say, this Raspberry Pi can only do one thing, it can play this PowerPoint, but really stable. So the other show I'm currently involved in is a plasma performance with a Tesla coil and lots of music. And it's a big light show. But I don't know if you can already see it. I will show you a couple of, we talks of time. Yeah. So you might see that the actors here actually are pretty dark. Yeah, so it's a great light show, but so even her here, it's really hard to see. So she's the main character doing this light show, and because of the plasma coil, and also people come to the stage, and you have these halogenic tubes which light up automatically because of all the electricity in the air. But I really like this show, but kind of sort of, it's so sad that she doesn't play a role in it. She's basically invisible the whole time. And so we said, okay, how can we now put her more in the center? And so I finally want to, so our goal is actually next year that I build the costume for her. And we will have neon tubes on her body, which then also can be remote controlled with the computer she will wear on her back. And so you can actually interact with this. Also there are lots of things she does live on stage. So kind of having wireless control and kind of touch sensors on the clothes would actually highly benefit her to interact with everything which is happening there. So let's see if we can find a couple of the videos there and get you excited. That's why I need internet. Where's this here? And I think I have a couple of pretty cool small videos. Sorry, let's kind of trusted. Why doesn't here user content? Probably. today. It's kind of a little goth. It's kind of, she talks a lot about telepathy and doing things wirelessly and magic in this context. Okay, let's see something else. Where's the stuff with the light? So this is this person's PhD thesis, yeah? She can actually play different tones on the plasma. So you see? Ah, enough. Yeah, so think out of the box. Let's continue. So, working with artists, things kind of got very quickly sort of led to the other. So I was connected to a group of students who got a grant for, sustainable technology use in your home environment. And this is called Nino, which is the nest. And it's basically a space where these artists work together. They also gave classes for students how to use the technology for them. So basically very similar to what I do in my in introduction classes, kind of building a weather station, measuring environment data, and then doing some stuff with this. But instead of making graphs with this, what these people did was actually turning that into visualizations and turning that into music. Here's kind of the prototype we built for actually having, so this came out of a tree, and so there were, it looked like when it got dark that out of the tree, the roots were sprouting as LED strips. So basically we connected a galvanometer, which is a lie detector, to a tree, and then visualize the life signals of the tree and turn that into visualizations. They also, so you see a little bit here, they turned the whole garden into a forest. So they, instead of doing monoculture, just grass and one or two trees, they planted a lot of trees, different trees which supported each other. They had the surface of the ground in a nice cover, so that it was always humid. They were measuring that and confirming that their house had a better climate already than the neighboring houses. And so I thought there was kind of lots of nice ideas playing together. They had a lot of network problems where I was allowed then to support them a little bit, so I stabilized a lot of things in kind of gathering the data and recording the data for them. Let's check that out. They have a couple of showpieces on the net too, so that you have a better idea. So here you can see a little bit this So now, a little demonstration here of what we have done recently. So why don't you give the plant some air? Yeah. So we basically measure the life science of the plants. So you can actually reflect how you treat the plant. Okay, that was just a button. So now, where do we have the other things here? Ah, yeah, I know where. In my Google Drive. New public. Here you see the LEDs outside. So that's in the real house, and there you see the signals of the plant, how they reflected and kind of come down the tree. It's really pretty. So, and depending on the wind blowing and the air, that what was actually looking different. And there you see the contacts to the plant which we used as the input. Okay, let's look at the other things. Okay, there you see basically that they kind of worked so much in making things nice in the garden, which is kind of the floor cover. I think they worked over a year and they grew tons of things, coffee plants, which support then other plants. Not totally all understandable, but there's a lot of dynamic between the plants they build up there. And then they use the tag to kind of check that everything is in order. But they also measure this data and then turn into music, so you can listen to a plant day. So you can basically hear in the music when it starts raining, when the sun is coming up. So I think that was some great work in terms of awareness building. And on the day I see kind of one of these boxes where we have all the controllers in. Let's see the other one. Ah, yeah. And they had some inside installations too. So that's something like 20 exponents in this house where they have arts. See, they'll use lights in different ways. They use CDs to break the lights and have RGB and a controller, air humidifier, which supports the plant again. So not all of them are interconnected, lots of them are interconnected, but basically there's lots of things that are also just interconnected with being in the same space and being in the same topic. Good. This was Nino. Yeah, you might know the guy up there. Good. Which led to me working further with some of these artists. So we built two pieces for the local museum. One is actually a piece which was also installed in Nino. So basically, we had a sensor installed in this plant, and this was triggering some stuff in this weird hairpiece you see back there. So basically we're looking at the plant and then the hair was moving. It's a little creepy, but was kind of a fun experience to actually do. You see when we designed this box for moving the hair around, so we used different motors which kind of made waves in the hair. And another fun project was here this hammock. And so the thing with the hammock was kind of inspiring people to take more time and kind of be more relaxed. And so when you lay down in the hammock and are very still, you get a nice animation of arts with a projector on you. So here's actually there's a little Raspberry Pi here with a projector which projects up to the ceiling. And so if you lay down and are really still, then you see this kind of display of different art pieces up there. As soon as you start moving again, it goes away. Then you have to wait, be quiet again, and enjoy that. And so there was a Raspberry Pi with ulno IoT running there, which was both controlling the hammock and this other installation piece back there. Yeah, okay, it's fine. I have a little animation where you kind of see the motor, but so we 3D printed these kind of wings for the motor, so to have kind of a nice round surface on there, so we can easily move the hair around. But yeah, depends on what you choose, but so it's kind of nice connectivity between different arts pieces we can see here. So this was a project, Digital Identity or Interactive Mural was a project where we actually got a little bit of money to build a huge LED installation, and it was called an interactive mural. So we wanted to have something, so the George Mason University has something with murals, so they have a lot of kind of just drawn arts on the wall, and they wanted to have something kind of a tech mural. And so we got one of the 2 spots for actually funding and building an arts piece. And here you see where we started putting all the LED strips down, and then getting them finally lit up to the point where we are able to do some really nice graphics on there. And then here you see them in the final installation, which is in the entrance of the makerspace. So they now have a big display at night where they show the makerspace. But we wanted to have, again, something interactive. So the idea was that you can actually connect this to a Twitter feed and interact with your identity, which you kind of get in this pixelated manner there on this huge screen. So I don't know if you get an idea of the dimensions. So that was kind of about this high and this wide, and we had about 4,000 LEDs on this. There's actually a 1,000-watt power supply driving this. This is really bright. So, and I have a little movie for that one. How do I open that? Not like this. Yes. So there, is it running? No, it's not running. There you can see it in action. So we're a little bit working on getting a new grant for the Internet of Arts. Yeah, so not Internet of Things, but for the Internet of Arts, and that's one of our showpieces in there. And so as you can see, this is all kind of with reflecting on our selfie culture and how we deal with that. Yeah, there are just some of the images we have there. So then we kind of were thinking, how can you destroy your own selfie? So we're kind of experimenting with manipulation of these images and giving the viewer the possibility to interact with it and kind of do something to yourself or your digital representation. So you can basically tweet your own image and then it's on there. And of course, as these artists, they want to ask questions and kind of make us reflect on technology and what we have there. Are we starting over? No, not yet. It's kind of hard to capture this, so because it's so bright, it's kind of a really different feel if you are right in front of it. And we connected it to different Twitter channels just to also see them coming. So it basically takes all the images which come out of a specific Twitter channel. And yeah, we do this with Node-RED. You know, the goal is actually, so now that we have built it, we want to connect more sensors to it, more. So initial goal was actually to use a heart rate sensor and kind of synchronize kind of the pumping of the image to our own heart, but this hasn't been done yet. That's one of the different animations we tried. Good. Starting to run out of time, but we're actually pretty good in time. So the most recent thing, what I did was actually building an artificial window. Oh. I think that was the end of the movie or another movie. I'm not interested in autoplay. My trip to Japan, okay. So this is basically a window which is supposed to create daylight for people who have to work in the basement. It's probably a foreign concept for you, but in the US, most offices don't have windows. And lots of people have to work without any daylight over the day. So the idea is to create something like daylight. And so I was inspired by a YouTube video to do something like this. So I really like the idea of having this reflective surface with crumpled aluminum in the in the back, and then use it to diffract the light to be more natural. It's hard to capture. This is actually brighter than you think it is, but it's hard to capture with the normal camera because the light is not taken really right. But so we actually added sound, so this could actually also make bird sounds, water sounds, and then also color RGBs to have some kind of idea of some grass and blue sky in there, so we could have different settings. It also had a Halloween mode where it could do lightning strokes and blood, and you had some screams coming there, but that was more like a gadget. But of course you can connect this to the internet and then have the real weather pattern inside than you have outside. It might be nicer to have real windows, but I still think it was a nice motivation here. So again, I would highly encourage go more often to the Ars Electronica Center. There's a nice project where, when I visited this time, where I thought, hey, that's super easy to build with the scale. I don't know if you know the music bottles, and they just have different weights in the the stoppers which are up there for the lids. And with the different weights, you can actually detect which of these have been taken out, and then you can play different musics or actually combine music in there. So I thought, oh, that's a project I would really like to do myself, and which would be very easy for my students to replicate. And there's another thing with big walls, with big displays you can slide. And so the trick there is basically having these big displays and then nice laser-based distance sensors in there. So with the time of flight sensor we had, we could easily replicate also that art piece, which is there. So when we're done today here, you will continue with this here. So I would like you to replicate the little power management scenario I had here. I don't think that you need much more than 10 minutes. Some of you might have to do some LoRa stuff still. But first, I want you to start building the team. Yeah, I still think 4 to 6 persons is the best. If it comes out, you have a big project, take 8. But if you want to have more than 5 persons in your team and want at least a leader, if you have more than 6, if you have more than, as with 6 at least, I want you to have a leader which is kind of like a product owner, and I want you to have a logistics master which just makes sure that the team works well. So something like a scrum master. So if you have 6 persons, have 2 leaders, or 8 persons have 2 leaders in the team. 4 persons, you can just work with each other. Yeah, so I would like to sacrifice the first half an hour, if not even hour now of the lab, of you just talking to each other. So I want you to crazy run around, ask others for their projects, and try to see if people fit together and think they can combine their scenarios or find a nice scenario to do this project together. So I want at least today that you find your teams.
So is this project a combination of our first project, or should we
This, both possible. Now you can, if it fits, reuse yours. If it doesn't fit, make something new. I don't give you any restrictions there. It needs to fit with your other members, and it needs to make a nice story.